Today I'm going to take you through the entire process, from mining and discovering raw gold to melting and refining it, and finally polishing and shaping it into gold bars or coins. The U.S. Mint and Treasury Department published the official figure for how much gold is stored at the Fort Knox Bullion Depository. As of the most recent publicly available data, Fort Knox holds about 160 million troy ounces of gold, which is roughly half of the U.S. government's total gold reserves. This means the gold represents only a very small portion of the national debt, roughly 2% or less. Even if the government sold all of its gold, at current market prices, it would cover only a small part of the debt and would come nowhere near paying it off. Operated by the U.S. Department of the Treasury, this vault is heavily secured and not accessible to the public. Right now, gold is trading at $4,600 per troy ounce, reaching its highest level in history. Right now, you're watching $600,000 worth of gold being poured. Federal government jobs at Fort Knox average around $107,000 per year, about the $52 per hour. This includes factory workers inside the gold vaults, as well as technical and supervisory roles in government service at Fort Knox. Right now, you are looking inside the vault at Fort Knox, which holds approximately 4,500 tons of pure gold. This is what the highly secure and top-secret weighing and storage of gold bars worth trillions of dollars looks like. A standard gold bar weighs about 27 pounds, but its value can exceed $500,000, depending on the market. Gold is one of the rarest materials on Earth. Yet it's found in everything from ancient treasures to modern smartphones. It can't be created in a lab and never rusts, but where does it actually come from? The answer begins far beyond our planet. Gold was created billions of years ago during the explosive deaths of stars and in neutron-star collisions, where extreme heat and pressure forged heavy elements. New gold is mined every year, roughly 3,500 metric tons annually. So in that sense, more gold is added to the total stock each year. However, due to high demand, this increase is not sufficient. Almost 50% of all gold above ground, or about 95,000 metric tons, is owned by private individuals and is typically held in the form of jewelry, bullion, and coins. Because native gold can sometimes be found without advanced technology, it played a crucial role in early human history. Long before modern mining, people could collect and work gold using simple tools, making it one of the first metals ever used by humans. Unlike many metals, gold has a unique chemical stability that allows it to exist naturally in a pure metallic form. This form is known as native gold, and it means gold is often found uncombined with other elements in nature. While metals like iron or aluminum are usually locked inside ores and must be chemically separated, gold can appear as visible metal in rocks, veins, or loose sediment. Gold is found in the Earth's crust, usually formed by hydrothermal processes, hot mineral-rich fluids moving through cracks and solidifying into gold veins. Right now, you are watching gold being mined at an open-pit mine in Ghana. Africa is currently one of the largest exporters of gold to the United States. Today, humans extract gold primarily by mining it from large open-pit or deep underground mines located around the world. Once the gold-bearing ore is removed, it is crushed and processed using methods such as cyanide leaching, which dissolves the gold from the rock. Gold doesn't corrode, rust, or tarnish, which is why even bars buried for centuries remain shiny and untarnished. After Earth formed, most of its natural gold sank into the planet's core. The gold we mine today, however, largely came later, brought by asteroids during the late heavy bombardment around 4 billion years ago. The heaviest gold bar ever made weighs about 55 pounds and was cast by Japan's Mitsubishi Materials Corporation in 2005. Even at that weight, the bar isn't massive. Its size is only about 15 inches in each dimension. The process is not that difficult, but it does require a furnace capable of reaching temperatures of around 2,200 degrees Fahrenheit, For gold to be liquid, it must reach a temperature of 1,200 degrees. Nitrogen and borax are added to remove impurities, while sand and soda ash help retain the heat so the gold doesn't cool too quickly. This keeps it liquid and makes pouring easier. Did you know that the average human body contains about 0.2 milligrams of gold, mostly in the blood and brain, making it tiny but real? Once everything is ready to be poured, you can now see the gold flowing and there are no solids. In this activity, utmost prudence is essential, and the worker must possess extensive experience to handle molten gold safely and skillfully. The casting process is extremely delicate, and even a small mistake can lead to serious errors or accidents. They wear specialized heat-resistant suits, gloves, and face shields. Even a small mistake could result in severe burns or the loss of enormous value. The facilities where they work are among the most secure in the world. Workers are thoroughly vetted, and movements are monitored by cameras and security personnel. No one handles the bars alone. Every step from casting to weighing to storing is supervised. Unfortunately, nearly 99% of the Earth's gold is locked deep within its core, far beyond our reach. This means we must focus on extracting as much gold as possible from the land and deposits available near the surface. While the process itself is not overly complicated, it does demand careful preparation and a furnace capable of reaching extremely high temperatures, approximately 2,200 degrees Fahrenheit, to melt the gold safely and efficiently. The United States has the largest gold reserves in the world, totaling 8,133 tons. Most of this gold is kept in Fort Knox, Kentucky, the Denver Mint, and the West Point Bullion Depository. Fewer than 5% of U.S. gold reserves have ever been physically audited by external parties. Last year, China produced the most gold in tons, followed by Russia in second place, Australia in third place, and the United States as the fourth largest gold producer. The gold bar begins to harden quickly, and after about 30 seconds, it becomes quite firm. This gold brick is almost cooled and can now be worked and polished. To cool it down, it is simply placed in clean, cold water. Producing pure gold is a highly specialized industrial process that requires heavy machinery, controlled chemical reactions, and strict safety protocols. Attempting anything like this at home isn't just impractical, it can be extremely dangerous. The factory worker places it in a water bath, and within a few minutes it cools enough to touch. Then the gold brick is taken out and given a thorough cleaning. In this case, this gold factory is trying to achieve 95% purity. They do this by using reagents, so they add sand, borax, sodium carbonate, and nitrate. That black is obsidian, and it is desirable to remove it to achieve pure gold. Every official bar has stamps showing the refinery, purity, serial number, and sometimes the year minted, which makes each bar uniquely traceable. Gold ingots produced in factories typically come in a variety of standard shapes and forms. These can include rectangular bars, cast bars, minted bars, smaller bullion bars, and even coins, each designed to meet different needs for storage, trade, or investment. Together, these substances retain heat, maintain fluidity, and remove impurities. That's why from the top there's that black slag around the gold brick you see right now. Gold bars are stamped for several important reasons. Each bar shows which company produced it, ensuring identification of the refinery. Occasionally, gold bars also bear the year in which they were minted. These markings serve several important purposes. They help verify the authenticity of the gold, provide traceability to its origin, and allow for accurate assessment of its value. Such information is essential not only for trading and investment purposes, but also for safe storage, auditing, and record keeping, ensuring that every transaction or transfer of gold is transparent and reliable. The stamp also indicates the gold's purity, usually 99.5% or higher, and the exact weight of the bar. Unique serial numbers make each bar traceable and help prevent fraud. Since around 2010, central banks worldwide have collectively shifted toward purchasing gold, marking a significant reversal of the decades-long trend of selling it. The countries leading this renewed accumulation include Russia, China, India, Turkey, and Poland. each actively increasing their reserves. This shift has been largely motivated by the desire to diversify holdings away from reliance on the US dollar, as well as to safeguard national wealth amid growing global economic uncertainty and geopolitical tensions. By strengthening their gold reserves, these nations aim to create a more stable financial foundation and reduce vulnerability to fluctuations in international currency markets. Gold bars worth billions of dollars are stored in bank vaults. Central banks, major commercial banks, and specialized bullion banks maintain highly secure underground vaults for this purpose. Some counterfeiters create fake gold bars by covering tungsten, which has the same density as gold, with a layer of real gold. In 2020, more than 80 fake bars were found in Chinese banks. Gold authenticity is checked using X-ray fluorescence, weight and size measurements, and ultrasonic testing. When gold is transferred between banks or countries, the process is extremely controlled and discreet. Transport is usually carried out by specialized security companies, using armored trucks, secure containers, and sometimes even military escorts for large transfers. Air transport is also common for international shipments, with gold shipped as cargo under tight security and insurance. Interestingly, much of the time gold doesn't physically move at all. Instead, ownership is simply transferred on paper between accounts held at the same vault. Physical movement only happens when absolutely necessary, since it's costly, risky, and logistically complex. 1 gram of gold can be stretched into a wire more than a mile long, or hammered into a sheet thinner than a human hair. Because gold does not oxidize when exposed to air or water, it doesn't rust or tarnish. That's why ancient gold artifacts buried for centuries in tombs or lying underwater in shipwrecks can be recovered looking almost as bright and intact as the day they were made. Some gold mines use special microbes that break down rock and naturally release tiny particles of gold. In a way, these microorganisms digest the minerals around the gold, leaving the metal behind, an actual biological process used in modern mining. An estimated 20 million tons of gold are dissolved in the oceans, but the concentration is incredibly low, only about 100 millionth of a part per million, making extraction economically unfeasible for now. This is the Bureau of Engraving and Printing in Fort Worth. Federal employees print more than half of all U.S. paper currency here at Eden. On average, the Fort Worth facility produces more than $29 million of banknotes every hour, which works out to hundreds of millions of dollars per day. These printing machines produce banknotes almost automatically. So this is where your inflation actually begins. The stacks of dollar bills you have at home were made in this printer. Bureau of Engraving and Printing has been printing money like wild in an effort to pay down the roughly $38 trillion debt of the United States. There are currently approximately 65 billion notes in circulation among American citizens. While it is not new for the government to print money to cover some debt, what is new is that 40% of existing US dollars have been printed in the last 12 months alone. Inside this American factory, billions of dollars are printed each day. FW on a dollar banknote means that it was produced in Fort Worth, Texas. In the 1950s and 1960s, $1 could buy far more goods and services than it can today. Because of long-term inflation, the US dollar has lost over 90% of its purchasing power since the early 20th century. As you can see, the whole production process starts with the design of new banknotes. Experts in design, security features, and history are consulted to ensure the note is visually appealing, secure against counterfeiting, and historically or culturally accurate. In-house artists and designers make the first sketches. They decide where to place the portrait, the background patterns, and the symbols. These sketches are then checked to make sure they look good and can be printed properly. The design process starts with simple drawings of the front and back of the bill. These drawings are then turned into detailed full-color versions. The designs are reviewed and changed many times before they are approved. This whole process can take up to 3 years, depending on how complex the design is and what security features need to be added. Next, it is time to prepare the banknote paper. U.S. banknotes are made from a unique blend of 75% cotton and 25% linen, giving them a fabric-like feel. This is what makes them durable and difficult to tear. It takes about 8 days to produce a U.S. dollar bill from raw paper to final circulation's ready form. The cotton and linen mix gives the bills a unique texture, making it easier to feel the difference between real and fake notes. Holographic images are made using a process called microreplication. A special type of film is first imprinted with the holographic pattern. This pattern is then transferred to a foil strip used in U.S. currency. The hologram is not simply printed. As you can see, it is applied using a special coating or foil material that gives it a shiny, reflective, and interactive appearance. Now comes the production phase called intaglio printing. This printing technique is crucial for both the visual quality and security of the banknote, as it makes the bills difficult to counterfeit. This engraving process is incredibly precise and detailed, allowing for fine lines, text, and images with remarkable clarity. The designs are engraved into steel plates. An engraver uses a sharp tool or specialized machine to etch the design into the surface of the plate. Each plate can carry only a single color at a time, so multiple plates are used for different ink colors. The term painting is sometimes used informally to describe the printing process, which involves multiple techniques and color layers. Each bill is inspected for errors such as smudging, ink misalignment, or missing security features. Now, counterfeit bills can be easily detected due to imperfections in the intaglio printing process, making it a crucial security feature of U.S. paper money. However, U.S. dollars are not hand-painted. They are printed using a combination of traditional methods and modern technology. There are only 2 places in the United States where U.S. banknotes are made. One is in Fort Worth, Texas, and the other is in Washington, D.C. You can tell a Fort Worth banknote by a small symbol printed on it. You are now watching the banknote paper being processed and prepared for cutting into individual bills. In short, if the Federal Reserve wants to change the number of notes in circulation, it instructs the Bureau of Engraving and Printing, which then prints the notes. The U.S. government has no direct influence on the number of banknotes printed. The number of new banknotes is determined and ordered by the Federal Reserve. Employees in this government agency are required to follow strict safety precautions. Over 60% of U.S. dollars are held outside the United States, making the dollar one of the most widely used currencies in the world. Each U.S. bill has a unique serial number that helps identify it. The serial number has 8 digits, and the 2-letter prefix corresponds to the Federal Reserve District that issued the bill. For example, a movie ticket that once cost only a few cents now costs several dollars, and a new car that used to cost under $2,000 now costs tens of thousands of dollars. But it remains the world's main reserve currency, and most global trade, including oil, commodities, and international loans, is priced in dollars. Central banks around the world also hold large amounts of U.S. dollars as part of their reserves. The Bureau of Engraving and Printing can print about 8,000 sheets of U.S. currency per day. Each sheet contains 32 bills, which totals roughly 250,000 bills per day. After paper production comes the printing process, followed by cutting and sorting. The final part of the production process is packaging and distribution among the Federal Reserve Bank. Each sheet of paper is checked for quality and consistency. This includes inspecting the weight, texture, and security features of the paper. If any defects or inconsistencies are found, the sheets are discarded. 1 ton of $100 bills is worth about $95 million, a huge amount that shows just how much U.S. money is in use. After drying, long sheets of paper are cut into smaller sheets that are the correct size for U.S. banknotes. These sheets are then ready for the next stage, which is the printing process. Bills last longer when they are used less frequently, so higher denomination bills tend to last longer because they are used less often than lower denominations, like $1 bills. Believe it or not, in 1930 you could buy 8 movie tickets for $1. In 1960, the power of a dollar was such that it could buy you 5 hamburgers. And 25 years ago, in 2000, a gallon of gas cost only $1 on average. And this is the way the US dollar loses value over the decades. Unfortunately, this process happens to all currencies around the world. These production halls are secure storage areas monitored by state-of-the-art surveillance systems. The team of people who produce American money is huge. Around 1,500 employees and contractors work at facilities in Washington and Fort Worth. Cameras are placed throughout the vaults, warehouses, and transportation routes to provide real-time monitoring of the currency's storage and handling. The average wage for these factory workers is just under $40 per hour. These workers serve as loaders, supervisors, and, to a large extent, as service staff who operate the printing machines. Although about 40% of Americans are cashless in their weekly spending habits, more than $2 trillion of U.S. currency is in circulation. Before bills are allowed to enter circulation, they undergo a rigorous inspection process using specialized cameras and software. The offline currency inspection system ensures that no defects or errors have occurred during production. Bills that do not pass this inspection are discarded, ensuring only perfectly produced currency reaches the public. While the $1 bill does not include all of the features seen on higher denominations, other bills have more advanced security measures. These include subtle background colors, larger denominations featuring a portrait watermark visible under light, and ink that shifts color when tilted. The distinctive green color of U.S. paper currency was chosen because green ink was abundant and resistant to chemical fading, making the notes harder to counterfeit. Each U.S. bill is embedded with red and blue security fibers that are distributed randomly, adding an extra layer of protection. Employees working in these facilities are trained to operate the special machines that produce the intricate designs, which are then stamped onto the banknote paper. Their main responsibility is to oversee and control the entire banknote production process. The printing machines at the Bureau of Engraving and Printing in Fort Worth are made by Koenig & Bauer AG, a German company and one of the world's leading manufacturers of banknote printing presses. The special banknote paper used by the BEP is supplied by Crane Currency. There are 2 main manufacturers of these machines for the BEP. Unlike regular office printers, currency presses are special security printing machines that are not sold to the public. Only a few companies in the world make them for national mints and central banks. Komori Corporation makes security printing presses, including offset, intaglio, and numbering machines. Their machines are used by central banks worldwide, including for U.S. currency, and are known for precision and reliability. Koenig & Bauer Banknote Solutions is a German company that makes banknote printing equipment used globally. Many banknotes are printed on their machines, though the exact models used by the U.S. government are not publicly shared. Since 1955, all U.S. notes must include "In God We Trust." Also, the portraits on the bills must be of deceased individuals. By law, the BEP itself operates the presses and handles much of the maintenance. According to their own documentation, they use state-of-the-art intaglio presses, 57-ton machines, and large offset presses. To make counterfeiting harder, different parts of a bill's design, such as the portrait, lettering, ornaments, and other elements, are each engraved by different, specially trained engravers. The currency is stored in high-security vaults that are designed to prevent unauthorized access. The vaults are equipped with multiple layers of physical security, including reinforced steel doors, advanced alarm systems, and 24/7 surveillance. It is often necessary to transport huge amounts of cash. Dunbar Armored is one of the companies that provides armored transport services for U.S. currency and other valuables, including U.S. dollar paper money. You are now watching the Cash Services Department at the Federal Reserve Bank of Cleveland. Here, around 800,000 banknotes are processed every day. These machines examine each banknote to verify its authenticity, detect counterfeits, and determine whether the note is fit to remain in circulation. When banks deposit excess cash, Federal Reserve staff carefully unload the money and feed the notes into high-speed sorting machines. In the past, the Cleveland Federal Reserve did more than just shred old money. Older reports show that the bank used to recycle about 1,500 pounds of shredded currency each day into paper products. On a wider scale, some Federal Reserve banks have also reused shredded currency in other ways, such as turning it into compost, building insulation, or small novelty items like piggy banks filled with shredded bills. The specific uses can vary depending on each reserve bank and local recycling programs. If someone has badly damaged or mutilated currency, for example, when less than half of the note remains, or it is in very poor condition, it is not processed by the Federal Reserve. Instead, it is sent to the Bureau of Engraving and Printing. Banknotes that pass the fitness check are not destroyed. They are gathered again into straps and bundles. These fit notes are then combined with new notes from the Bureau of Engraving and Printing and sent back into circulation to meet cash orders from banks and other financial institutions. The notes are printed slightly bigger than their final size, then mechanically trimmed. This allows the BEP to remove any rough edges and ensure every bill has perfectly clean borders. The BEP's Mutilated Currency Division examines the damaged notes, and if they can verify the value and confirm that the notes are genuine, they issue a reimbursement check. Certain security techniques used in U.S. bills are not publicly disclosed. Even employees often only know their narrow part of the process. The distinctive green color of U.S. paper currency was chosen because green ink was abundant and resistant to chemical fading, making the notes harder to counterfeit. While U.S. paper money is mostly made of cotton and linen, other countries like Canada and Australia have adopted polymer notes, which are more durable and also more difficult to counterfeit. Euro banknotes include multiple advanced security features such as holograms with a portrait of Europa, watermarks, microprinting, raised print, and embedded security threads. Euro banknotes are generally more durable and long-lasting than U.S. currency, also due to their materials and advanced production techniques. The 200 euro banknote is produced using a combination of intaglio printing, offset printing, and letterpress printing. They are more resistant to wear and tear than U.S. dollar bills, which tend to degrade more quickly over time. The European Central Bank is responsible for overseeing the production and issuance of euro banknotes, including the 200 euro note. The production of 200 euro banknotes varies depending on demand, but millions of these notes are printed and distributed each year to meet the needs of Eurozone countries. A security thread embedded in the note runs vertically through the paper and becomes visible when held up to the light. This thread contains the printed 200 euro denomination. The visible security thread and the unique embedded paper design make euro banknotes harder to counterfeit. Some denominations, such as the 100 euro and 200 euro notes, include a hologram of the euro symbol and denomination number that changes color and appearance when the note is tilted. Compared to U.S. dollar notes, euro banknotes generally use more advanced and varied anti-counterfeiting features, making them more difficult to replicate. Around 1 trillion euros worth of euro banknotes is estimated to circulate outside the Eurozone, primarily in countries that use the euro as a de facto currency. The ECB continuously monitors the production and distribution of euro banknotes to prevent fraudulent activity. As of 2025, more than 25 billion euro banknotes are in circulation, representing a value of several trillion euros. Printing takes place in highly secure facilities to prevent the illegal production of counterfeit notes. Euro banknotes are printed in several European countries, including Germany, France, and Austria. Each country operates its own high-security printing facility, but all follow strict ECB guidelines. While euro banknotes depict Europe's cultural and architectural heritage, euro coins feature different national designs on one side to reflect the individual identities of the Eurozone countries. The 50 euro banknote is the most widely used denomination across the euro area. With around 8 billion notes currently in circulation, it represents almost half of all euro cash in use today. Its popularity comes from its balance between value and practicality, making it ideal for both everyday transactions and savings. The cost of producing a euro banknote varies depending on its size and the number of security features it contains. On average, it costs between 6 and 10 cents to manufacture a single note. This includes the specially treated paper, high-precision printing, and the application of advanced security elements designed to prevent counterfeiting. If a banknote is accidentally damaged, it can usually be exchanged for a replacement at a bank, provided most of the note is still intact. Euro banknotes are produced exclusively at high-security printing facilities. Across Europe, 12 printers are currently accredited by the European Central Bank to manufacture euro banknotes. These facilities operate under strict security rules, and every stage of production is closely monitored. The paper used for euro banknotes is made from pure cotton fiber rather than wood pulp. This gives the notes their distinctive texture and significantly improves durability, allowing them to withstand years of circulation. Higher value notes, such as the 100 euro, are especially robust and increasingly used, particularly during periods of high inflation. Throughout the production process, quality control plays a crucial role. Workers regularly inspect the thickness of the paper and the precision of the ink application. Under large magnifying devices, inspectors carefully examine each printed detail to ensure absolute perfection. Even the smallest printing flaw can lead to a note being rejected and destroyed. Inside a euro banknote factory, employees handle billions of euros in value every single day. Despite this, the money is never considered currency until it officially enters circulation. Until then, it remains a tightly controlled product, treated with the same level of security as any high-value asset. Between 6 and 8 billion banknotes are printed each year to meet demand and replace those that have become worn or damaged. After printing, the large paper sheets are cut into individual notes using fully automated cutting machines. The finished banknotes are then counted, stacked, and packed into boxes by robotic arms, ensuring speed, accuracy, and security. Once packaged, the boxes are sealed, labeled, and loaded onto pallets ready for distribution to central banks across the euro area. From there, the banknotes enter circulation, passing through countless hands and becoming an essential part of everyday economic life in Europe. It costs between 6 and 10 euro cents to produce a single euro banknote, including ink, paper, and printing. The cost varies by size and security features. Damaged notes can often be replaced at a bank. Euro banknotes are printed in highly secure money factories. The 50 euro note is the most widely used denomination in the euro area. About 8 billion 50 euro notes are in circulation, representing nearly half of all euro cash. Euro banknotes are automatically packed into boxes using robotic arms. More than 30 billion euro banknotes are in circulation, with a total value exceeding 1.7 trillion euros. During quality control, workers carefully check the thickness and consistency of the applied ink. The exact color composition of the ink is kept secret to prevent counterfeiting. There are 12 high-security banknote printing works across Europe accredited by the ECB. 100 euro banknotes are made from pure cotton fiber, which increases durability and gives them a distinctive texture. European banknote printing machines run almost continuously, stopping only for maintenance. Security within the factory is at the highest possible level. Employees are subject to strict background checks and continuous monitoring to prevent theft or unauthorized access at any stage of production. Once printed, euro banknotes are either stored in high-security vaults or prepared for transport. They may be shipped by road, sea, or air to central banks around the world. where they will eventually be released into circulation. Before packaging, the banknotes are checked and counted once again. They are then wrapped in self-sealing plastic film and carefully stacked in sturdy cardboard containers, slightly larger than a shoebox. This precise packing ensures both protection and efficient handling during transport. Quality control is continuous throughout production. At every stage, individual sheets are randomly selected and closely examined to ensure consistent quality and to detect even the smallest printing errors. The sheets are also counted repeatedly as they move through each phase of the printing process, guaranteeing that no discrepancies occur. One crucial step involves the printing of serial numbers. Special stamping machines apply the serial numbers to each banknote. These machines are adjusted for an entire series at once, rather than for individual notes, ensuring uniformity across millions of banknotes. It costs more to make a penny than it is worth. The cost to produce a 1-cent coin is approximately 1.7 cents due to rising material and labor costs. Similarly, a nickel costs around 7.4 cents to produce. The serial numbers are printed using a glossy, high-tech ink containing special pigments. When the banknote is tilted, the color of the number shifts from emerald green to dark blue. It's an important security feature that helps the public identify genuine notes at a glance. Every euro banknote carries a unique identity, a combination of 2 letters and 10 digits. The first letter of the serial number reveals the printing facility where the banknote was produced, allowing each note to be traced back to its origin. The United States Mint is the primary agency responsible for producing coinage for the United States. Established in 1792, it operates minting facilities in Philadelphia, Denver, San Francisco, and West Point. These facilities produce circulating coins, metals, and commemorative gold, silver, and platinum coins. The U.S. Mint produces billions of coins every year to meet circulation demand, serve collectors, and replace worn or damaged coins. In 2025, the U.S. Mint produced more than 14 billion coins, including pennies, nickels, dimes, quarters, and dollar coins. Every coin begins its life as a blank metal disc with no images, lettering, or value. These blanks are known as planchets. Only after they pass through several preparation steps are they ready to be struck. In a single stamp striking machine, planchets are transformed into finished coins. Each machine can strike around 400 coins per minute, applying a pressure of up to 180 tons to imprint detailed designs onto the metal surface. Once minted, the coins are poured into massive containers and transported by workers to the next stage of the production process. From there, they are sorted, counted, and prepared for distribution. Each year, the U.S. Mint produces approximately 33 billion coins. While most are destined for circulation within the United States, a significant portion is also exported to other countries. These high-speed machines produce thousands of coins per minute, which are then delivered to banks based on orders from the U.S. Department of the Treasury. This has led to ongoing debate in the United States about whether these coins should continue to be produced. The U.S. Mint uses high-speed coin presses that can strike up to 750 coins per minute. In a single shift, a press can produce up to 5 million coins. The penny has been in continuous production since 1793, making it one of the oldest coins in U.S. history. Laser technology is also used to engrave highly detailed designs onto dies with exceptional precision. Its designs have changed many times, including well-known versions such as the Lincoln Memorial and the current Shield design. This is the United States Mint in Philadelphia. The U.S. Mint works closely with the U.S. Treasury Department and Congress to select designs for new coins. Old and worn coins are regularly collected and sent back to the U.S. Mint to be recycled. The metal from old coins is melted down and reused to produce new coins, helping to reduce material costs. Modern coins are made from carefully selected metals such as zinc, nickel, copper, and aluminum. These materials are delivered to the mint in the form of long metal strips, which are fed into powerful blanking presses. The presses punch out thousands of perfectly round metal discs that will later become coins. In the United States, there are currently 4 active coin mints: Philadelphia, Denver, San Francisco, and West Point. Each facility specializes in different types of coin production, from everyday circulation coins to proof and commemorative editions. The Philadelphia Mint is the largest of these facilities. It operates more than 60 coin minting machines, and when all of them are running at full capacity, the factory can produce up to 50,000 coins every minute. The U.S. Mint uses specific metal alloys depending on the type of coin being produced. For example, pennies are made from copper-plated zinc, while quarters are composed of a copper-nickel alloy. The raw metals are purchased from suppliers and melted down to form ingots. The molten metal is then rolled into thin sheets, which are punched into small round blanks called planchets. These blanks are roughly the size and shape of the final coin, but do not yet have any designs on them. The planchets are fed automatically into a coining press, a machine capable of striking large numbers of coins very quickly. Metal dies are pressed onto the planchets under extreme pressure, imprinting the designs on both sides of the coin. This process also stamps the denomination and mint mark, such as P for Philadelphia. Coins, such as dimes, quarters, and half dollars, have ridged edges, which are added to prevent the illegal practice of clipping small amounts of metal from coins. The edges are milled after the coins have been struck. Finally, the coins are thoroughly inspected for defects or errors. Any imperfect coins are removed from the batch. In some cases, coins intended for collectors are polished to give them a smooth, shiny appearance. Due to high inflation in recent years, higher value coins are increasingly used in daily transactions, while low value coins, such as cents, are becoming less common in everyday circulation. The cost of producing coins has risen in recent years. For example, the cost of minting a single dime increased to around 6 cents in the past year, reflecting higher metal and production costs. Historically, coins were made from valuable metals such as gold, silver, or bronze. Today, more affordable and durable materials like zinc, nickel, copper, and aluminum are used instead. In 2025 and 2026, the Philadelphia Mint continues a tradition that stretches back more than 230 years, making it the oldest operating mint facility in the United States. One interesting fact is that most circulating U.S. coins made in Philadelphia still do not carry a mint mark. Pennies, nickels, dimes, and quarters struck there usually appear blank under magnification, where other mints show a letter. This long-standing tradition often surprises collectors who expect every coin to show its origin. The Philadelphia Mint does not primarily make coins for collectors. In 2025 and 2026, its main job is producing circulating coinage, the everyday money used in stores, vending machines, and banks across the country. The median amount of money that a typical American household holds in transaction accounts is about $8,000. This median figure means half of Americans have more than this amount and half have less. Because a small number of people have very large balances, the average amount is much higher, around $62,400. Many Americans have very modest balances. Surveys show roughly 28% of adults have less than $1,000 in savings, and a significant share have only a few $100s set aside. Data also reveal that a large portion of the population would struggle with unexpected expenses. Less than half of Americans have enough readily available cash to cover 3 months of basic living costs. Savings vary widely by age and income. Younger households and lower-income households tend to have much smaller balances than older or higher-income ones. Right now, you are looking inside the vault at Fort Knox, which holds approximately 4,500 tons of pure gold. Operated by the U.S. Department of the Treasury, This vault is heavily secured and not accessible to the public. Right now, you're watching $600,000 worth of gold being poured. Today, I'm going to take you through the entire process, from mining and discovering raw gold to melting and refining it, and finally polishing and shaping it into gold bars or coins. Right now, gold is trading at $4,100 an ounce, reaching its highest level in history. This is what the highly secure and top-secret weighing and storage of gold bars worth trillions of dollars looks like. New gold is mined every year, roughly 3,500 metric tons annually. So in that sense, more gold is added to the total stock each year. However, due to high demand, this increase is not sufficient. A standard gold bar weighs about 27 pounds, but its value can exceed $500,000, depending on the market. Almost 50% of all gold above ground, or about 95,000 metric tons, is owned by private individuals and is typically held in the form of jewelry, bullion, and coins. Gold was created billions of years ago during the explosive deaths of stars and in neutron star collisions, where extreme heat and pressure forged heavy elements. Gold is found in the Earth's crust, usually formed by hydrothermal processes, hot mineral-rich fluids moving through cracks and solidifying into gold veins. Right now, you are watching gold being mined at an open-pit mine in Ghana. Africa is currently one of the largest exporters of gold to the United States. Unlike many metals, gold is rarely found combined with other elements. It often occurs in its pure metallic form, known as native gold. Today, humans extract gold by mining it from open pit or underground mines and refining it through processes such as cyanide leaching, smelting, and electrolysis. After Earth formed, most of its natural gold sank into the planet's core. The gold we mine today, however, largely came later, brought by asteroids during the late heavy bombardment around 4 billion years ago. Gold doesn't corrode, rust, or tarnish, which is why even bars buried for centuries remain shiny and untarnished. Did you know that the average human body contains about 0.2 milligrams of gold, mostly in the blood and brain, making it tiny but real? The process is not that difficult, but it does require a furnace capable of reaching temperatures of around 2,200 degrees Fahrenheit. For gold to be liquid, it must reach a temperature of 1,200 degrees. Nitrogen and borax are added to remove impurities, while sand and soda ash help retain the heat so the gold doesn't cool too quickly. This keeps it liquid and makes pouring easier. Once everything is ready to be poured, you can now see the gold flowing and there are no solids. Unfortunately, 99% of the Earth's gold is in its core, so we need to try to get as much gold as possible from. In this activity, it is necessary to be prudent, and the worker must have great experience to know how to work with molten gold properly. This casting process can easily go wrong. The facilities where they work are among the most secure in the world. Workers are thoroughly vetted and movements are monitored by cameras and security personnel. No one handles the bars alone. Every step from casting to weighing to storing is supervised. They wear specialized heat-resistant suits, gloves, and face shields. Even a small mistake could result in severe burns or the loss of enormous value. The heaviest gold bar ever made weighs about 55 pounds and was cast by Japan's Mitsubishi Materials Corporation in 2005. Even at that weight, the bar isn't massive. Its size is only about 15 inches in each dimension. Last year, China produced the most gold in tons, followed by Russia in second place, Australia in third place, and the United States as the fourth largest gold producer. Producing pure gold is a highly specialized industrial process that requires heavy machinery, controlled chemical reactions, and strict safety protocols. Attempting anything like this at home isn't just impractical, it can be extremely dangerous. The United States has the largest gold reserves in the world, totaling 8,133 tons. Most of this gold is kept in Fort Knox, Kentucky, the Denver Mint, and the West Point Bullion Depository. Fewer than 5% of U.S. gold reserves have ever been physically audited by external parties. This gold brick is almost cooled and can now be worked and polished. To cool it down, It is simply placed in clean, cold water. The gold bar begins to harden quickly, and after about 30 seconds, it becomes quite firm. In this case, this gold factory is trying to achieve 95% purity. They do this by using reagents, so they add sand, borax, sodium carbonate, and nitrate. Together, these substances retain heat, maintain fluidity, and remove impurities. That's why from the top, there's that black slag around the gold brick you see right now. That black is obsidian, and it is desirable to remove it to achieve purer gold. The factory worker places it in a water bath, and within a few minutes it cools enough to touch. Then the gold brick is taken out and given a thorough cleaning. Every official bar has stamps showing the refinery, purity, serial number, and sometimes the year minted, which makes each bar uniquely traceable. Gold bars are stamped for several important reasons. Each bar shows which company produced it, ensuring identification of the refinery. Gold ingots from production factories usually come in several standard shapes and forms, such as rectangular bars, cast bars, minted bars, small bullion bars, or coins. The stamp also indicates the gold's purity, usually 99.5% or higher, and the exact weight of the bar. Unique serial numbers make each bar traceable and help prevent fraud. Sometimes the year the bar was minted is also included. These markings ensure authenticity, traceability, and value verification, which are crucial for trading, storing, and auditing gold. Some counterfeiters create fake gold bars by covering tungsten, which has the same density as gold, with a layer of real gold. In 2020, more than 80 fake bars were found in Chinese banks. Gold authenticity is checked using X-ray fluorescence, weight and size measurements, and ultrasonic testing. Since about 2010, central banks have been buying gold overall, reversing decades of selling. The main recent buyers are Russia, China, India, Turkey, and Poland. This shift is driven by the desire to diversify away from the US dollar and respond to economic uncertainty. Some countries, such as Russia and China, use gold to bypass sanctions, lessen dependence on the dollar, and create alternative economic systems. Gold is viewed as a safeguard against currency devaluation, inflation, and political instability. When gold is transferred between banks or countries, the process is extremely controlled and discreet. Gold bars worth billions of dollars are stored in bank vaults. Central banks, major commercial banks, and specialized bullion banks maintain highly secure underground vaults for this purpose. Transport is usually carried out by specialized security companies, using armored trucks, secure containers, and sometimes even military escorts for large transfers. Air transport is also common for international shipments, with gold shipped as cargo under tight security and insurance. Interestingly, much of the time gold doesn't physically move at all. Instead, ownership is simply transferred on paper between accounts held at the same vault. Physical movement only happens when absolutely necessary, since it's costly, risky, and logistically complex. 1 gram of gold can be stretched into a wire more than a mile long, or hammered into a sheet thinner than a human hair. Because gold does not oxidize when exposed to air or water, it doesn't rust or tarnish. That's why ancient gold artifacts buried for centuries in tombs or lying underwater in shipwrecks can be recovered looking almost as bright and intact as the day they were made. Some gold mines use special microbes that break down rock and naturally release tiny particles of gold. In a way, these microorganisms digest the minerals around the gold, leaving the metal behind, an actual biological process used in modern mining.